Welcome to Introduction to Composites. Today is the third day of the ongoing week, and today we will continue our discussion which we had yesterday related to coupling responses in composites, and specifically what we are going to do today or discuss today is the coupling between the bending response of a plate and the twisting response of a plate. So, that is what we plan to discuss today. Bending, twisting response. And specifically what we will explore is that how this kind of coupling, so I will call it coupling, how this coupling can be minimized. So, we had earlier explained that this is attributable to elements D16 and D16 and D26 in the D matrix, and let us look at the definition of these elements. So, D16 equals sum of Qij for the kth layer Hk cube minus Hk minus 1 cube. So, this is Q16, and here this is entire thing is divided by 3, and this is summed over every single layer if there are n layers in the system, and this is Q16 bar. And similarly D26 equals 1/3 of Q26 bar for the kth layer Hk cube minus Hk minus 1 cube. Now, how do we make sure that these numbers, these values D16 and D26 are eliminated? So, method 1. So, what is method 1? That if for all layers either theta is 0 or theta is 90, then Q16 bar is equal to 0, and that means D16 equals 0. Similarly, Q26 bar is 0, and that implies D26 is 0. Okay. So, this is one approach. But a limitation these types of laminates is that these laminates which are only oriented either in 0 degrees or 90 degrees, the layers, is that they are not strong in other directions. So, these types of laminates, cross ply laminates, are not preferred a whole lot in real systems, because they may be strong in 0 degree or 90 degree direction, but in other directions they may not be strong. So, if I bend it in some other direction, they may easily crack or break. So, we do not like these types of laminates. Then there is another method. So, in the other method what we have is, if we have a layer oriented at theta above the mid plane at a certain distance, and if we have another layer at an orientation negative theta below the mid plane at the same distance, then their contributions will add and cancel out. So, let us look at this method. So, here for each theta layer Z1 distance away from mid plane, we introduce negative theta layer minus Z1 distance away from mid plane. So, this is what we want to do. So, let us make a picture of it. So, let us say this is the laminate this is the mid plane. So, this is z is equal to 0. There could be one layer and this is oriented at theta degrees, and this distance is z1. So, this is coordinate is z1, this coordinate is z2. Then there is another layer oriented at minus theta, and here the coordinates are minus z1 and minus z2. So, if we look at the contributions of these two, so let us say this is L1 and this is L2, contribution to D16 from L1, what is it? It is Q16 bar for the layer L1. So, first we will actually calculate for L2, not L1. So, it is L2. So, this is Q16 bar for L2 times Z2 square, no, Z2 cube minus Z1 cube into 1 by 3. Okay. And contribution from D2 contribution from L2, what is it? It is Q16 bar for L1, oh, I am sorry, yeah, for L1. So, this is L1 and it is minus Z1 cube minus Z2 cube. So, that means it is Z2 cube minus Z1 cube into 1 by 3. Okay. But Q16 bar for L1 is equal to negative of Q16 bar for L2, because the theta for L1 is negative, okay, and Q16 is an even function of odd function of theta. So, if this is the case, then these two contributions add up and cancel out. So, if for every theta layer I have another negative theta layer on the other side of the mid plane, then the contributions are going to cancel out. So, in this case, D16 and D26 will be 0. So, overall D16, D26 they can be made 0. But there is a problem with this solution also, because here D16 and D26 will be 0, also because there is also one theta layer and there is also an equivalent negative theta layer, A16 and A26 will be 0, but the laminate will not be symmetric, the laminate is not symmetric, and because laminate is not symmetric, it means that the B matrix will not be 0. So, we are able to decouple extension and shear response, we are able to decouple bending and twisting coupling, but bending and extensional coupling is not decoupled because B matrix is not 0, and this is a much bigger problem than solving the other eliminating the other couplings. So, again we do not like this solution also. Theoretically we can design systems which have D16, D26 to be 0, but it comes at a cost that either it should be 0 9 cross ply laminate, or it should be an non-symmetric laminate, an anti-symmetric laminate, okay. But that is something we really do not want. So, we are stuck. So, the third approach is that we do not want to get maximum possible, we do not necessarily want exactly 0 values for D16 and D26, rather we will say that okay, how much small we can make these values to be. So, method 3 Method 3 is minimize. So, we do not try to make it 0. So, we minimize D16 and D26. We minimize D16 and D26. So, how do we do that? So, we do that using some guidelines. First thing is number of layers should be large. Okay. Second, for each layer at theta, we put another layer at minus theta, but not on the other side of the midplane, but rather what you do is adjacent to it. Adjacent to it. Okay. So, these are the two guidelines, and if we do that in a smart way, then this helps reduce D16 and D26 significantly. So, what does this second condition mean? That suppose there is a theta layer, then there should be another layer negative theta next to it. So, okay. And so, suppose this is 0, 90 and symmetric. So, 0 degree will not contribute to D16, 90 will not contribute to D16, theta layer will contribute, but there is a negative theta layer next to it and it will cancel some of the effect, and the overall laminate is still symmetric, which ensures that B matrix is 0. Also, because there is theta layer and negative theta layer, A16 and A26 will be 0. D16 and D26 will not be exactly 0, but they will be reduced. So, what we will do is we will actually do couple of examples and see how this method works. Okay. So, we will do 3 cases. So, case 1. So, suppose there is a stack up, okay, and so this is -9. So, these are the coordinates -8, -7, -6 and -5, okay, and these are theta, 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 theta. And then let us say this is a symmetric laminate, suppose this is symmetric laminate. So, same thing on the other side also exists, suppose this is the line of symmetry, okay, and let us say, so it is like this. So, this will 9, 8, 7, 6, 5, and let us say between +5 and -5 all layers are 0 or 90. So, the only things which are generating D16 are these theta layers, okay, only things. So, contribution of these 4 top layers will be what? So, contribution from the top layers, so all the middle layers are going to contribute nothing, because all these are so this is all 0 degree, okay. So, what will be the value of D16? D16 will be Q16 bar times 1/3, and you can consider these 4 layers as one fat layer. So, this is -5 cube minus -9 cube, because you can consider this as one single fat layer, okay. So, if you do this, you see that it is equal to Q16 bar divided by 3 times, and if you do all the math, it comes out to be times 604. So, this is case 1. 604 times Q16 bar divided by 3. This is case 1. Next what we do is we have the same layer, but we change some thetas with minus thetas. So, in the second case what we do is, so this is case 2. So, we have theta, minus theta, theta and minus theta, and we are only going to compute the contribution from the top half. The second, bottom half will just double, so it does not really matter, right. So, this is the overall layer. Okay. So, again this is minus 9, minus 8, minus 7, minus 6, minus 5, these are the coordinates, and we are just seeing the contribution only from the top half. So, what will be D16? D16 will be, so we will start from this, so we will go like this. So, D16 will be equal to, so first we do, so let us say this is layer A, no we'll, so this is equal to, so this is the layer which is closest to the mid plane is having an orientation of negative theta. So, let us say its Q16 is minus Q16, because it is, so minus Q16 bar divided by 3 times minus 5 cube minus 6 cube. This is the contribution from L1 plus contribution from L2, this is L2. So, this is equal to Q16 bar by 3. So, here it is positive Q16 because theta is positive, okay, times minus 6 cube minus 7 cube, okay, plus Q16 bar by 3. So, this is L3, this is minus 7 cube minus 8 cube plus Q16 bar by 3, and what you get is minus 8 cube minus 9 cube, okay. So, if you do all the math and you add up everything together, what you get is Q16 bar divided by 3 times 84. So, here what we have done is we have added, we have a stack up sequence theta minus theta, theta minus theta. So, they are cancelling. Here it was Q16 bar divided by 3 times 604, but just because we have put theta minus theta, theta minus theta, this kind of a sequence, that 604 becomes smaller and it becomes 84. There is even a better way, and that is case 3. And here let us say this is the mid plane. So, this is theta, this is minus theta, this is minus theta, and this is theta. Okay. So, coordinates are minus 9, minus 8, minus 7, minus 6, minus 5. Okay. Here let us compute D16. So, D16. So, let us do for L1, then we will do for L2, then L3 and L4. So, for L1 it is Q16 bar by 3 times minus 5 cube minus 6 cube plus, now L2 and L3 they have the same orientation. So, I can consider them as one single layer, okay. I can consider them as one single layer, or I will, just to be consistent, I will consider them as 2 layers, does not matter, I will get the same answer. So, Q16 will be negative of this times, so for layer L2 it is minus 6 cube minus 7 cube plus minus Q16 bar by 3 minus 7 cube minus 6 cube, oh I am sorry, this is 8 plus Q16 bar by 3 minus 8 cube minus 9 cube. And here if you add up everything together, what you end up is Q16 by 3, so this is all Q16 bar times 12 times 12. So in case 2 it was 84, in case 1 originally it was 604 and it has come down to a very small number 12. And the reason this third case is better than second case is because if you look in the second case, here we have a 9 cube term and that is being reduced by a 8 cube term from here, okay. And then so 9 cube is larger than 8 cube, so it, and then again we have a 7 cube term here and that is being reduced by a 6 cube term from the layer below. In this case we have a 9 cube term and we have an 8 cube term, so that gets reduced, but then here we have a 8 cube term which is of opposite sign and that is getting reduced by a 7 cube term. So this total may be a positive number, this total may be a negative number. So these two branches or bundles also cancel out each other. So the contribution for this and the contribution from this. So again I'll explain that. Contribution from this cancels contribution from this and we get some residue and let us say that is a positive number. In the lower portion, contribution from this and contribution from this cancels out, but it is not exact cancellation and the residue is negative number, and then this positive and negative number also cancel out each other. So because of this third stack it provides even a lower value of D16. So the point is that using these types of approaches we can reduce D16, D26 to a small number, and for such stacks A16 and A26 will be anyway 0 because for each theta there is a negative theta layer, and for such stacks B will also be 0 because the overall matrix is overall lamination sequence is symmetric. So in this way we are able to get exactly B is equal to 0, that condition. We are also able to exactly ensure A16 and A26 is 0, and we can reduce D16 and D26 to a fairly small number, so that the coupling between bending and twisting is also minimized, not exactly made 0 or eliminated, but minimized. And in this way we have a system which behaves in the way we would like we would ourselves like it to behave. So this is what I wanted to discuss about bending, extension and coupling, and tomorrow we will talk about another lamination sequence in context of isotropy. So that is what we plan to discuss tomorrow. Until then, have a great time. Look forward to seeing you tomorrow. Bye.